Okay, this would be VodCast 9-4, dealing with just the topic of percent yield. Now, when we have been doing stoichiometry problems up to this point, what we have been calculating in our mass-to-mass calculations has been what has really been what's referred to as a theoretical yield. A theoretical yield, by definition, is this definition right here. It's the maximum amount of product that can be produced from a given amount of reactant. So it's basically a mass-to-mass stoichiometry problem, and it's theoretically what we really should get. In the lab that we just completed, the bicarbonate dilemma lab, okay, you calculated theoretically what we should get. Okay, so in a perfect world, okay, if a farmer plants 100 seeds, then their theoretical yield they would get 100 plants to grow. Okay, so that's kind of the perfect theoretical yield. Okay, now what we're going to look at here is we're just going to do a quick stoichiometry problem where I calculate how much Fe3O4 is produced from 4.5 grams of Fe. So this is just a mass-to-mass stoich problem. So I'd like you to go ahead and set that up and do that. So setting this up, we have 4.5 grams of Fe, okay, and we need to change that to moles of Fe, so we're going to multiply by the molar mass of Fe, which is pretty simple in this case because it's just one element. And then we're going to multiply by the mole ratio between Fe and Fe3O4, which is a 3-to-1 mole ratio. But since we're looking for the Fe3O4, we'll put 1 mole Fe3O4 all over 3 moles of Fe. And then we're looking for mass, so we'll multiply by the molar mass of Fe3O4, which is 231.5 grams Fe3O4 per 1 mole. Okay, and if we do all the math, and I want you to do the math just to check, okay, what we get is 6.22 grams of Fe3O4. So first of all, this is just a straight mass-to-mass calculation, but this 6.22 is the theoretical yield. That's, in theory, what we should get. So in theory, if I start with 4.5 grams, I should produce 6.22 grams. Now, the practical never works out perfectly. So what happens is we will always get what's referred to as an actual yield. An actual yield is the amount of product that is actually produced during a chemical reaction. And that's because not all reactions are 100% efficient. Okay? What could happen is, as you mix things, some reactant could get stuck on the side of a test tube or the side of a beaker, or you don't mix it thoroughly. So what really happens in the real world is you never produce 100%. Okay, so what's going to happen is we're going to get an actual yield that is not 100%. Okay, so just sticking with my farmer example, the amount that the farmer actually grows might be 85 seeds. Okay, so they theoretically should have got 100 plants to grow. They actually got 85 plants to grow. Well, this is what is referred to as percent yield. And percent yield, this is the textbooky definition. It's the ratio of the actual yield to the theoretical yield. And really what this is how you calculate your grade. Okay, you got 55 out of the total 65 possible points. Well, you calculate your percent, that's your percent yield. Well, percent yield, the way you do it is you take your actual yield and you divide it by your theoretical yield, and then multiply by 100, and that's your percent yield. So, just to deal with this in our previous problem, we said that our theoretical yield was 6.22 grams of iron. But let's say we did the reaction and we only produced 5.3 grams. So the 5.3 grams is the actual yield, okay? And the 6.22 grams is the theoretical yield. Okay? So if I want to calculate what the percent yield would be, I would take 5.3 divided by 6.22 and then multiply that by 100. And if you do that, in this particular case, the percent yield is 85%. So I got 85% of what I should have got. Okay? So, let's see how this would be in a problem. Okay, so here I have a problem that says with 36.8 grams of C6H6 is reacted with excess chlorine, I want to know how much C6H5Cl is produced. So this is really back to a traditional mass-to-mass problem. Okay, I just want to do a mass-to-mass with that. So go ahead and set that up. This is good practice, that's why we're doing it. So when I'm setting this up, okay, I have 36.8 grams of C6H6. I need to change that to moles. Okay, my mole ratio is pretty simple in this one. It's a 1-to-1 mole ratio. So 1 mole C6H5Cl to 1 mole C6H6, and then the mass, 112.5 grams C6H5Cl to 1 mole. So when I set all that up and do the math, I get a theoretical yield of 53.1 grams of C6H5Cl. That's a 5. Okay, now continuing with this problem then, if only 36.8 grams was produced from the actual reaction, what's the percent yield? So the whole idea here is you may have to do a mass-to-mass stoic problem to find your theoretical yield. Then you can do a percent yield. So in the percent yield, now it's pretty easy. It's just 36.8, which is our actual yield, and that's grams, divided by 53.1 grams times 100. And I just put the grams in there just to kind of prove that those cancel out. And so this gets you 69% yield. So there are different types of problems. So here we're kind of back to a simple word problem. A chemist carried out a reaction that should produce 85.8 grams of product according to calculations. The chemist was only able to recover 58.9 grams of product. What is the percent yield? So this is a pretty simple basic problem, and you should just be able to calculate this quickly. The whole idea here is pick out what is the actual and what is the theoretical just from the wording. So this is my actual, and this is the theoretical. So to make this calculation, I take 58.9 divided by 85.8 times 100. And for some odd reason, that is also 69%. So something to remember, when you do an actual stoic calculation, that is the theoretical yield. Anytime you do a mass-to-mass calculation, that's the theoretical yield. The only way you know the actual yield is if you do a lab or you are told in the problem. Okay, so that is something that kind of has to be told to us at this particular point. Okay, so I have two more example problems I'd like you to do. Okay, I'd like you to do this one. And then there's a second one, so please, okay, if you don't want to watch this because you understand it, fast forward and watch the next one, please, because the next one problem is kind of different. But go ahead and work this problem out totally. Obviously, one of the first things that you will have to do is write the reaction. The nice thing about this one is everything's kind of a one-to-one. Okay, now you do have another situation here. You got a couple numbers here. You got to make sure you pick out what number is what. So this is my starting amount of calcium carbonate, and that's what I want to do a mass-to-mass with. So in this particular problem, you don't know, okay, the two final numbers, and that's often a mistake. Some people want to go ahead and take this and divide it by this, and that's not what you do. Okay, you got to do a mass-to-mass here. So I have 32.7 grams of CaCO3, and I need to do a mass-to-mass between these two to find out what mass of product I actually should get. So this is 1 mole of CaCO3 per 100 grams. The mole ratio is easy, 1 mole of CaO to 1 mole of CaCO3. And then 56 grams of CaO to 1 mole. Okay, and doing all that, what we calculate is that we should get 18.3 grams of CaO. Now, that is the theoretical yield. Because I actually did a mass-to-mass stoic problem, 32.7 grams of this should produce 18 grams of CaO. Now, this goes back to the problem as far as what you have. You have 13.7 grams of CaO. That's what was produced. So that 13.7 is your actual. So if I want to find the percent yield, I have to take 13.7 divided by 18.3 times 100. And that gives me 75%. So, point being, sometimes you have more than one number. You got to think about what the numbers actually mean in the problems. Now, one last problem, okay? And this is a problem to figure out, okay, if I'm given a percent yield, how can I find out what the theoretical yield should have been? And this is a lot of just algebra. Okay, so here a chemist obtained 77%, obtained a percent yield of 77%, and the actual yield we knew was 14.7 grams. So what we want to figure out is what the theoretical yield should have been. So going back to our equation, we have actual yield divided by theoretical yield times 100 equals our percent. Okay, so putting in the numbers, now this is really just algebra. I'm solving for the theoretical yield here. So my actual is 14.7. I am just going to put the value of x in here because it's easier to solve for x than to just to write out theoretical yield every time. So I have 17.4 divided by x times 100 equals 77%. percent. Now, math-wise, okay, this is algebra, but the easiest thing to do is get rid of this 100 by dividing both sides by 100. And so what I'm left with is 14.7 over x equals 0.77. And yes, quite honestly, I would expect you can do that in your head. Now, okay, this is where people get lost in algebra. Okay, I'm going to rewrite this. 14.7 over x equals 0.77. I need to solve for x. Okay, I'm going to do this the very, very long way. In order to get x, you need to multiply both sides by x. That cancels the x out over on this side, and that leaves me with 14.7 equals 0.77 times x. Now, I want to divide by 0.77. And that gives me x by itself. And remember, x is our theoretical yield. So that's what I want to find. And when you do that, that gets you 19.1. And now you want to put grams back in here because it's a gram value. And of course, you could check this, right, to make sure your number is right by substituting this back in and taking 14.7 divided by 19.1 times 100, and guess what we should get? 77. So you can actually always check your answer on this particular one as well. But the idea is the algebra is the issue, so you might want to follow through that algebra one or two more times. You should be able to complete the next worksheet.